The world's largest ocean bridges, built over decades, billions of rupees spent. But one question: why do deaths, disappearances, and conspiracies follow every major project? These bridges aren't just concrete and steel. They're stories of human sacrifice, the limits of technology, and secrets buried beneath the ocean. Today we're uncovering deep-sea engineering, building the world's most impossible bridges. We're revealing what they want to keep hidden. 1. The impossible challenge. Imagine standing in the absolute middle of the ocean. Around you, the water is hundreds of feet deep, hiding a world of crushing pressure and unpredictable currents. The wind here doesn't just blow, it screams with the force of a hurricane. The very air you breathe is thick with salt, a silent chemical that eats through solid steel as if it were paper. This is one of the most hostile environments on Earth. Now, imagine trying to build a 6-lane highway right through the heart of it. For centuries, the idea of an ocean-crossing bridge was nothing more than a fever dream of visionary architects, an engineering impossibility that defied logic. But today, the impossible is where we drive our cars every day. Thanks to a new generation of Godzilla-scale machinery and materials that defy the laws of nature, we are finally conquering the deep blue. 2. The foundation, battling the depths. The biggest challenge of an ocean bridge isn't the wind or the traffic above the water. It's the silent battle happening beneath the waves. To support a structure weighing millions of tons, you can't just rest it on the sand. Engineers must reach the solid bedrock, which can be buried under layers of ancient mud and silt. But how do you dig a hole in the middle of a moving ocean? The answer lies in two incredible feats of engineering. First, we have the cofferdam. Imagine a colossal, watertight steel cylinder, sometimes as wide as a basketball court, being lowered into the sea. Huge vibrating hammers drive these steel walls into the seabed until they are secure. Then, massive industrial pumps move in, sucking out millions of gallons of seawater until miraculously, you have a dry, safe workspace in the middle of the ocean. It's a man-made island where engineers can pour concrete just like they would on dry land. But when the water is too deep, even for cofferdams, we turn to the megapiles. These aren't your average construction beams. These are hollow steel tubes, some as wide as a small house and as tall as a skyscraper. To get them into the earth, we use hydrostatic pile drivers, behemoths of machinery that use high-pressure fluid to deliver blows with millions of pounds of force. Every strike sends a tremor through the earth, driving the pile deeper until it's locked into the planet's crust. This foundation is so strong that it's designed to survive catastrophic earthquakes, 100-year storms, and the relentless pounding of massive waves for over a century. This isn't just construction, it's an active war against the elements. 3. The heavy lifters. Mega machinery at work. Once the foundations are set, the next challenge begins. How do you place a road that weighs as much as a skyscraper in the middle of the sea? On land, you'd use a mobile crane, but in the ocean, normal cranes are useless. Everything here has to be bigger, stronger, and more resilient. Meet the floating shear legs, the heavyweight champions of the maritime world. These are just cranes. They are massive lifting machines, mounted on specialized ships that can stay stable even in rough swells. Some of these giants, like the ones used for the Hong Kong-Zhuhai Bridge, can lift over 12,000 tons in a single go. To make this possible, engineers use the precast method. Instead of pouring concrete over the water, which is slow and dangerous, entire sections of the bridge, complete with road markings and railings, are built on land in high-tech factories. These massive segments are then loaded onto barges and towed out to the site. This is where the magic happens. The floating crane maneuvers into place, hooks onto the segment, and lifts it with millimeter precision. Using GPS and laser alignment systems, the crane places the road onto the pillars. It's like a giant high-stakes game of Lego, but instead of plastic bricks, you're moving billions of dollars worth of infrastructure. One wrong move, one gust of wind, and you could lose years of work. This is precision engineering at its most extreme. 4. Nature's enemies: corrosion and currents. The ocean is not just a location, it is a hostile environment that actively tries to destroy everything we build. The biggest threat isn't a storm, it's the salt. Salt water is a chemical weapon that causes standard steel to oxidize and expand, cracking concrete from the inside out. To win this silent war, engineers use epoxy-coated rebar and specialized stainless steel that can resist corrosion for over a century. They even use high-performance concrete, HPC, which is so dense that salt molecules simply cannot penetrate its surface. But then, there is the raw power of the water itself, the current. In places like the Jiaozhou Bay, the tide moves with the force of 1,000 locomotives. If a bridge pillar was just a flat block of concrete, the vibration from the water will eventually shake the entire structure to pieces. This is why every pillar is designed with hydrodynamic shapes, curved like the hull of a ship or the wing of a plane, to let the relentless current flow around it without causing vortex shedding or dangerous vibrations. And for the ultimate protection, we install dampers. These are essentially giant high-tech shock absorbers hidden inside the bridge's structure. During a typhoon or an earthquake, these dampers allow the bridge to sway and dissipate energy. Instead of being rigid and snapping under pressure, the bridge breathes with the wind and the waves. It is the perfect balance between immovable strength and flexible intelligence. 5. Case study and the future. To see all this technology in one place, you only have to look at the Hong Kong-Zhuhai-Macau Bridge. Spanning a staggering 55 kilometers, it is a masterclass in modern engineering. But it's not just a bridge. It includes artificial islands and the 6.7-kilometer underwater tunnel. Why a tunnel? To allow massive container ships to pass overhead without the risk of hitting the bridge. This is what happens when human ingenuity meets the world's most powerful machinery. We don't just build over nature, we work with it. But we are only getting started. As we look to the future, the boundaries of what is possible are shifting again. Engineers are already brainstorming concepts for bridges that could cross entire oceans. We are talking about floating foundations that are anchored to the seafloor miles below, and carbon fiber cables that are 5 times stronger than steel but a fraction of the weight. We are moving toward an era where no distance is too great, and no ocean is too deep. The machines of tomorrow will be even larger, smarter, and more capable than anything we've seen today. The horizon is no longer a limit, it's a destination. 6. Conclusion. Every time you drive across a bridge over the sea, remember the invisible battle happening beneath your tires. The machines, the math, and the sheer bravery of the engineers who made the impossible a reality. If you enjoyed this deep dive into extreme engineering, hit that like button and subscribe to Machine Eyes 367 for more looks at the world's most incredible machinery. What's the most impressive bridge you've ever seen? Let us know in the comments below.